Okay. Hello and welcome to our Vital Vitamins case study. I'm team 2 and this is Nika. On this project, I work with Ali, Ashley, Alex, and Eliana. So to go over our agenda for today, I'll cover an introduction and then we'll jump into the problem statement, assumptions and constraints, order profiling, the flow network and rewards chart, operational plan, and finally an implementation plan. So to kind of cover our introduction, for a background, Vital Vitamins is an over-the-counter vitamin manufacturer. They're looking to build a new facility. So we want to support office, manufacturing, and storage divisions. They store and handle finished goods, raw materials, and packaging, and distributes through retail stores owned by Vital Vitamins and direct to consumer online and phone orders. So the motivation for this project is that Vital Vitamins needs to build a new facility to accommodate their expansion and meet 5-year growth requirements while minimizing overall costs. To kind of go over our problem statement, we have different categories here, and the overarching problem is that the current facility setup that Vital Vitamins has doesn't support future needs and goals, which will constrain growth and lead to missed revenues and customers. So our categories are kind of what is wrong, who is affected, and how bad is the problem. And I'd like to start with the inefficient truck unload times. The people who are affected are labor, shipping, receiving, and dock utilization. And how bad is the problem? 1 to 2.5 hours per truck with 2 employees. And also the manufacturing lines will not match future needs. So manufacturing and customers are affected by this. And the problem here is that we'd be unable to meet anticipated demand, which results in missed sales and unsatisfied customers. Next up, in-store price ticketing has high costs and rework. So the store associates are affected with this, and that results in an annual cost of $1 million. For our last problem here, picking orders uses a paper-based system, which is both unreliable and time intensive. So the people who are affected by this are picking labor, customers, if there are inaccurate data, and how bad the problem is that it's hard to update the picking orders, organize, or track them. So going into our assumptions and constraints, we had the 173,000 square foot area to start with, and we are able to increase that up to 215,000 square feet. We had 2,500 dedicated towards corporate offices, 4,000 towards manufacturing, 3,000 towards an outlet store, and 141,000 to 183,000 towards warehousing and distribution. If we were to include a mezzanine, it must be in this area. So with this leftover, warehousing has 70,817 square feet and distribution has 70,183 square feet. There could be 12 dock doors and a 12-hour operating day.
So moving on to some order profiling now. From these charts, we see an analysis of the actual Vital Brands products. On the left, we see Pareto analysis done to the types of items sold, so we can see the Vital Brands sales activity. And from here, you see that the weight loss and bodybuilder vitamins are really accounting for the bulk of the Vital Vitamins sales, specifically the weight loss vitamins. And on the right, we can see the Vital Brand sales growth from the current year to the projected design year, showing growth in sales. And this is going from year 1 to year 5 from 25% to around 33%. So we see about an 8% overall increase. Right here, we see analysis of the pick movement by total units moved. We can see that the large majority of these picks require between 15 and 100 feet cubed. And then even narrower, a lot of them are between 50 and 100 feet. So this is important for calculating our worker movement and figuring out our importance of items. Then moving on to some storage analysis. On the left, we see the percent of SKUs that require certain amounts of storage. We can see that for finished goods, they mostly require, the large majority requires very little space per item, less than 0.25 feet cubed. Whereas for raw goods, it's slightly more balanced, but still we have almost double the goods requiring 0.5 or more feet cubed of storage space. And this also can be attributed partially to how items are stored. Finished goods are smaller and in totes, whereas the SKUs are in bulk raw storage, are stored in pallets. And then moving on here, we can see the projected carton sales by year for direct consumer goods, store retail goods, and then overall. So direct consumer goods is projected to be increasing by 20% per year, whereas store retail by 10% per year. So this leaves us with a projected carton sales in our design year of 11,508.48 cartons per day on peak days. And then for direct consumer, that leaves us with 4,245.89 cartons per day. Oh, that one's for the retail. The 11,000 is the direct to consumer goods. And then this totals to 15,754 cartons per day overall. And then moving to our product flow. This is the functional flow network that we developed. With the idea of pallets. So we're bringing in 128 pallets a day, 32 of which of those are going directly to manufacturing. Those are from reserve. Those are our raw materials. For category C, that stays in the reserve area. That's 4.8 pallets. Category B is the bottom level pallet rack, and that's going to be 14.4 pallets a day. And then category A, where we really see the bulk of all our items, which has 76.8 pallets, will be taken to the carton flow rack. And then from these various areas of reserve, they are picked and moved to shipping.
So now we'll go over layout and space utilization for this project. Starting with the layout, we have the different departments as you can see in the picture and the different area assignments. So there was a required 3,000 square feet for the store outlet, 25,000 for the office. We allocated 4,000 square feet for manufacturing with a small area adjacent to it for a PPE station that is at 8 square feet. Then the largest areas are the reserve storage at 44,000 square feet and the flow rack at 30,000. We have 8,000 square feet for packaging, and then 14,000 for the shipping receiving area, and 900 square feet for the break room. So in all, we have allocated 141,908 square feet for these different departments, which results in about 82% space utilization. And so right now, the areas that are allocated have extra space for growth, and additional space is available beyond the initial equipment in storage areas. So we made this layout with the future growth in mind. Next, moving on to the REL chart. So first we laid out the various departments that we needed to have in our facility. Then we gave them a qualitative assignment based on how adjacent, if we want them adjacent or not. So using the standard ranking of, absolutely necessary to absolutely not, we assigned a point value to them, with absolutely necessary A being 8 and an absolutely not X being -8. So using those point values, we then converted our qualitative rankings to quantitative values for our different departments, which resulted in an A score of 56, a max A score of 65, and an overall A efficiency score of 86.15%. So now I'll also address the manufacturing and price ticketing decisions that we were prompted with in the case study. So starting off with the manufacturing lines, assuming that there are no changeovers, the daily production with the current lines 1 and 2 is at 39,550 units. If line 1 is converted to a high-speed line, this would increase to 53,550 units. And if line 2 is increased to a high-speed line, we would get to 58,000 units. So On peak days, we anticipate the need to produce about 60,000 units, and to meet this, we will convert line 2 to a high-speed line and produce a maximum capacity to build inventory needed for the additional 2,000 units on peak days that we would not get with just that modification alone. Next, with price ticketing. So although an internal audit revealed that we are spending $1 million on in-store price ticketing, our ultimate decision is to keep price ticketing at retail locations. And we chose this decision because it avoids additional product handling, which would be involved with breaking down and rebuilding individual units on pallets, the additional labor for increased handling and price ticketing, the 33% rework due to price fluctuations and changes, and also the unnecessary labeling of products that do not need to go into retail stores.
So moving on to our equipment selection, we as a group decided to have carton flow racks, pallet racks, palletizers, carton conveyors, a hand washing station, and multiple areas of PPE. We also decided to have forklifts and order pickers.
So moving on to our operational plan, we broke it down by department, starting with shipping, which obtains goods from storage and ships them out in pallets, cartons, and eaches. This department will be using forklifts and conveyors, as well as 3 employees. Receiving, which unloads pallets from trucks and moves them to reserve, they will require forklifts and 3 employees as well. Reserve storage, which is the initial point where all the pallets and cartons will go, will require pallet racks and 3 employees. Our manufacturing department, which processes our raw materials, holds our work in progress, and finished goods to go to the flow racks, that will require our conveyors, manufacturing lines, and a hand washing station. We will need 2 operators and 1 person to repair raw materials and 1 person for maintenance. Our carton flow rack, which is where our Class A items will be stored, will require our carton flow racks and an order picker, as well as 2 order pickers. The office, which will, keep our personnel, will require a warehouse management system and then 1 floor manager. Our outlet will require a forklift and 1 employee. And then finally, packaging, which is where we're creating rainbow pallets, will require palletizers with 2 employees. So as for our implementation plan, beginning in year 1, we will start construction on the manufacturing lines, the pallet and carton flow racks, our 12 dock doors, as well as our offices. We'll also be purchasing all of our material handling equipment. In year 2, we plan to hire 12 employees and begin training them on the new facility. We'd like to have those carton flow racks installed, as well as pallet racks, our finished manufacturing lines, and established locations for our material handling equipment. And then by year 3, we want to begin production of Vital Vitamin products on the manufacturing lines and hire 4 workers to train on that. And then also establish an order picking and packing area. By year 4, we want to then increase that production by 30% and hire 1 worker for our outlet, as well as 2 for shipping and receiving. And finally, by year 5, we want to be at full production to match our continuous growth, maintain continuous improvement and training, and hire 2 workers to accommodate that growth.
So as for the health, safety, and welfare of our employees and of our customers, for health, we are going to implement smocks, hair nets, beard nets, disposable gloves, and a hand washing station. As for the safety, we're doing safety goggles, tag in, tag out procedures, and we are requiring steel-toed boots solely for our manufacturing people, as well as a ton of safety training. And for the welfare, we are implementing company-wide bonding events, as well as we are putting TVs, couches, and kitchen appliances in the break room for our employees to enjoy and relax.
So moving on to our economic justification, our financial summary is we will need 21 employees. Our estimated salary or wage per hour at our designated location would be 17 per hour with 8-hour shifts, and that would get us to about 633,000 annually. For our financial summary of equipment, with all of our items listed here that we've referenced in previous slides, our total is looking to be 1,171,000.
So in conclusion, at a glance, our total equipment cost is $1,171,696.50. Our total annual labor cost is $633,000. The total number of employees that we're hiring is 21. Our space utilization for our facility layout is 82.03%. And the main attributes of our facility is that it's 173,000 square foot. We're going to convert manufacturing line 2 to a high-speed model. We are keeping the 12 dock doors, and we are also keeping price ticketing at retail locations. Thank you.